In this example, we're going to solve this linear system using elimination. So the first consideration that we need to make is to kind of ensure that both of these equations are written in standard form. So we have x, y, and then equals a number. So as I look at this first equation, this negative 8y, which is on the right side, kind of needs to bounce over here to the left side. So we're going to do so by changing its sign, by adding 8y to both sides. And the 9x stays on the left, and the 6 stays on the right. So the second equation, it looks like the 10x is over here on the left side, so this negative 2y needs to be brought over by adding 2y. And then this positive 14 needs to go over to the right as a negative 14. So kind of what I have going on now, I have my two equations. Both of them are written in standard form. So on one of these equations, I need to use the multiplication property of equality. I need to run a constant through and multiply every term by some constant. Well, what is that constant going to do, and why are we going to do it? So in elimination, I need to choose one of these variables so that their coefficients will be equal in number but opposite in sign. So on the x's, I have a positive 9 and a positive 10. And for my y's, I have a positive 8 and a positive 2. I see that the y's here, 8 and 2 is a factor of 8. If I multiplied 2 by 4, then they would both be 8. They are the same sign though, so I need to multiply by a negative 4. So when I multiply this second equation by negative 4, it's going to look like negative 40x minus 8y equals a positive 56. So when I write down my unchanged first equation, I notice that my y variables are ready to be eliminated, negative 8y and positive 8y. So when I add these two equations, the y's will be eliminated. So that was the point of multiplying by a negative 4, was to ensure that the coefficients of my y's would be equal in number but opposite in sign. So now let's add these equations. Negative 40x plus 9x is negative 31x, and 56 and 6 makes 62. So whenever I go ahead and divide both sides of the equation by negative 31, my value of x equals negative 2. So let's go ahead and take that negative 2 and plug it back in to one of these original equations. And let's go ahead and do it for no particular reason to this first one. So we have 9x, so 9 times negative 2 equals 6 minus 8y. So negative 18 equals 6 minus 8y. When I subtract 6 from both sides, I get negative 24 equals negative 8y. And dividing both sides by negative 8 will show me that 3 equals y, or of course y equals 3. So now I have both values, x as negative 2, y as positive 3. So I can write the solution as an ordered pair. And this ordered pair, negative 2, 3, is going to be the solution of this linear system.